Welcome back to another episode of Team Adams Teaching. Today we're going to be looking at multiplication rules of exponents, and this is part 1 of 2. Just for those who are new to exponents, this is the first time you're really getting into some new type of math you've never seen before. And so it's going to seem a little tricky at first, but stick with it. It does make sense, and you'll be good once you get to it. First off, we're going to look at how to multiply bases with exponents. And each one of these things has a name. The little tiny number in the upper right corner, that is your exponent. And then the number here, the big one, is your base. And the two together is called a power. So this is your base, and this is your exponent. And when we're looking at factored form versus what the actual answer is, for factored form, for 3 to the 4th power, what that means is you're going to take 3 and multiply it by itself 4 times. So 3 times 3 times 3 times 3. And we can do that 3 times 3 times 3 times 3, and we get 81. There are some shortcuts when you are factoring them. A lot of times what I like to do is say, hey, this is a 9, this is a 9, and together 9 times 9 is 81. So it's a little bit faster if you don't have a calculator. So here's how we're going to do this next part. We're going to start out, we're going to take each thing, we're going to expand it into factored form. And after a while, you'll think, I probably don't need to do this, but it's always a good way to check your answer to see if you've got it correct. So down here, you'll notice the first example is 5 squared times 5 to the 5th power. And they want you to just write the answer as a simplified exponent. And so 5 squared is the same thing as 5 times 5. And 5 to the 5th power is the same thing as 5 times 5 times 5 times 5 times 5. And if you put it all back together in simplified exponent form, that gives you 5 to the 7th power. There are 7 5s being multiplied by each other. So if we look at the next one, 2 squared, that would be the same thing as 2 times 2. And if you had to multiply that by 2 times 2 times 2 times 2, which is 2 to the 4th power, and put it all back together again, you would have 2 times itself 6 times. So the answer here, 2 to the 6th power. So we're going to do that. Some of these are going to take a little bit. We've got 3 to the 7th power, 3, 1, 2, 3, 4, 5, 6, 7, 7 of those guys, times 3 times 3, that's 3 squared. All together, how many 3s? Well, this is really 3 to the 9th power. And again, if you count them all up, you'll have 7 there, 2 there, for a total of 9. Same thing works now when you have variables. So these are x cubed times x to the 5th power. X cubed is the same thing as x times x times x. And x to the 5th power is x times x, 5 of those. And then if you put them back together, this is really x to the 8th power. Okay. This one gets a little tricky, and there's a little spot right here, which is why it gets tricky. So some one you want to pay close attention to. If I'm going to do x to the 3rd power, y to the 2nd power, that is x times x times x times y times, now this xy squared. This is the part where some students say, well, isn't this 2x and 2 x's, x times x, and then 2 of the y's, y times y? So here's what you need to know. Every single number or variable has its own exponent. And if it's not written in, it's a 1, that crazy one that's never there but is there. So like when we wrote just x, we used to say, well, that's 1x, but we didn't have to write the 1. So we're going to do something similar to that. Every single thing here has its own exponent. This x down here is x to the 1st power. And that squared only belongs to the y. So when we write this out, it's going to be x times y times y. So just 1 x there because that's x to the 1st power only. That leaves us with 1, 2, 3, 4 x to the 4th power times y to the 4th power. If you remember, usually we write the variables in alphabetical order, so x's come before y's in the alphabet, so that's how we write it as well. Then down here, we have 7 squared. That looks like 7 times 7. X to the third power is x times x times x times 7. And remember, that's just to the first power, so we just write one of them. And then times x is our x squared. And again, putting those back together again, we have 7 times 7 times 7, which is 7 to the third power. And then x times x times x times x times x, x to the 5th power. Okay. Which brings us to the first weird kind of thing. When they ask for simplified form, if it is a variable with an exponent, that is its simplified form. If later on, as you're doing these problems, you have a number to a higher power, then you actually need to go through and solve that as its number answer. If it says simplified exponent form, then we just leave it like that. But if it says simplify, and that's it, doesn't say in exponent form, then you would take this 7 and multiply it by itself 3 times and write that answer out. All right, last one here, we have 2 times, let's see, x times x times x times x for x to the 4th power, times 3 times x. Remember, there's x to the 1st power there, even though it's not written. And that squared goes to the y, so we have times y times y. So there it all is. Now again, this one, kind of 2 ways we can look at it. Really, if we leave them with just simple exponents, then it really is 2 to the 1st power times 3 to the 1st power times all of our x's, that's x to the 5th power, and all of our y's, that's y to the 2nd power. But 6x to the 5th power, y to the 2nd power is also correct, and that's a more simplified form. And technically, that's what you're going to do for all these problems. So if you can multiply out the numbers, you should, unless it asks only for simplified exponent form. Otherwise, change the numbers into whatever they are. For example, on this one, we would have 7 times 7 times 7, and that gives us 343 x to the 5th power. So we could do that one instead. So that leads us to our fancy rule, and our fancy rule is this. It's called the product of powers rule. There's a lot of them, and they all have similar sounding names, but it is this. If you have a base, like bases, and it's a to the m power times a to the nth power, what you really have is a to the m plus nth power. You're going to be adding up those exponents. And for most of you, you probably already figured that out while we were doing these problems up here. When I did 2 to the 2nd power times 2 to the 4th power, most of you knew that we're going to end up with 6 of them. We added 2 plus 4 to the 6th power. 3 to the 7th power times 3 squared, add up 7 and 2, you get 3 to the 9th power. Notice the base does not change. We are just adding up those exponents there. And we can only do that if the base is exactly the same, then we can add their exponents. So that's it for part 1. Stay tuned for part 2. Bye guys.